So to finish up lesson 2.1, part 1, the linear part of the lesson, we need to talk about linear correlation. Now, this first part is very much review. Our example we're going to look at how we can use the calculators to help us find information. So we'll be learning some new tricks there. About linear correlation, okay? When we graph tables of data using our stat plots, so when we graph dots, right, we can tell whether or not the dots are clustered along a line. If they are, we say that there is a linear correlation. If the line has positive slope, then we say there's a positive linear correlation. If the line has negative slope, then there is a negative linear correlation. And it's also possible for graphs to have little or no linear correlation. Excuse me. You guys have been doing this since what, at least middle school. You see the dots and, kind of imagine it without the circles there, but you see the dots, and these dots kind of angle up and to the right. Yes, they kind of cluster around an invisible line there, so to speak. And so with that, this first graph is an example of and they get specific here, strong positive linear association. Strong because the dots are tightly pulled together, and there's no hesitation. Which direction is this going? Is it positive? Is it not? It's a very strong correlation there. Now, this book gets a little more specific, and they also separate it down into, this one is a weak positive linear correlation. Can you still see the angle of the dots angling up to the right? Mm-hmm. You can. It's just they're not pulled in quite so tightly around that invisible line. Okay, so there's an example of a weak positive linear correlation. I'll be honest. I'm going to be more, can you identify as positive versus negative? Okay, we can argue the weak versus strong all we want, but, the important thing is positive versus negative. Down here at the other end, you see an example of a strong negative linear association where those dots are angling down to the right. Here we have the weak negative association. And in the middle, when the dots are scattered everywhere, we usually say no correlation. This says little or no correlation. That's old news, right? Okay. Now, what we're going to look at in example 4 is, okay, they give me a list of data, but we don't have any type of graph. Okay. Depending on the data, you might be able to kind of eyeball it and figure out, okay, is that is that going to be a positive correlation or a negative correlation, depending on how the data is listed, depending if it's organized, that type of stuff. But we're also going to look at how we can use the calculator to help us here. Okay, we have this technology. How do we use it? So, we're given a table of weekly sales data based on market research for prices of boxes of a certain breakfast cereal and the number of boxes sold. Describe the strength and direction of the linear correlation. So this is like a 3 or 4 part question here. Okay, so first thing we're going to do is describe the strength and direction of linear correlation. After we do that, we're going to work on figuring out how to write a linear model for the demand as a function of the price of the box. So when I say write a linear model, we're going to be writing an equation. Okay. Or shall I say our calculator is going to be writing an equation for us. So, no longer done by hand. And then, after we get that all done, we're going to use that model, that equation, to predict cereal prices if we were at a price not on that list there. Okay, what would follow the correlation there? So, first thing, describe the strength and direction of the linear correlation. Well, I don't know. Can you kind of guess, before we start putting some stuff in on the calculator, can you kind of guess if it's going to be a positive or negative correlation? Negative. Do you remember talking about that?
Negative.
Why?
Because the box is sold or going down.
But the price is going down.
Okay. So
inflation, basically.
Okay. When I've taught this at, lower levels, that's exactly, if we don't have a graph to look at, the price of boxes in order, yes. Okay, increasing order. So as the price of boxes are going up, the amount of boxes being sold is going down, yes. So if you've got one variable increasing, the other variable decreasing, that is an example of a negative correlation. Now, strong or weak? And that's where, and here, before we answer strong or weak, we're going to put this on the calculator because we're eventually going to have to get an equation. So, if you will, grab your calculators. And do you guys remember how we can put this information into these numbers into our calculators?
Is it like
List.
Second.
list, yeah.
Yeah. So I think I usually just hit the stat button right here to get in there. I don't think I usually hit second list, but we're going into list. I usually hit the stat button. And the very first thing there is edit. We're going to go in and we're going to edit. Now, if your calculator's like my calculator, there's junk already in there from the last time we used these. So remember, you have an option. You can delete individual entries, or you can clear a column. I prefer to go up top and hit clear, enter. Do not delete a column, please. It's a pain. So I'm going to clear each of my columns. And my recommendation of what I'm going to do is I'm going to make my price per box. I'm going to put those values in L1. And the boxes sold, I'm going to put those in L2. Fair enough? Do I need all those zeros on that first column? No. You do not. You want to save yourself some typing.
Oh my goodness, too many numbers. Oh, I forgot what to do next.
Me personally, I'm checking over my numbers to make sure I have them typed right.
I look at my numbers and I just look at them. So I don't know what's too many numbers. I mostly don't care.
Okay, do we have our numbers entered?
Oh yeah, okay. Why do we have to go back to school or back on Monday? I thought we went back to school on Tuesday.
Fall break's always been a Monday.
Right.
And hey, this week, spring break, you come back on a Monday also.
When is spring break?
March.
Don't we get like a Thanksgiving break or something?
Yeah.
How much is that?
3 days.
Oh.
Okay, are we good now? Almost good?
You can go ahead, you're good.
Yeah,
I'm
you-
almost done.
Okay. Okay, guys. So the next thing is we want to look at these dots, yes? If you just hit graph and go to your graph, are these dots showing up? Now, if I hit graph, oh, hey, look, I have whatever I last graphed in there. One thing I would recommend that you do, go into y equals and clear whatever you have in y equals, or turn them off. Now, here's an easy way to do this. While you're in y equals,
This is a plot thing, right?
can't you remember you can go up to the plots, and if the settings are already set, you can just hit enter here. And now that my plot 1 is darkened, plot 1 is turned on. So now if I go to my graph, I still don't see my dots.
Did you have like zoom out or something?
Okay, so here's the deal. I need to somehow adjust my settings, yes? Because what? My lowest Y value is 18,000. Yuck.
That's far.
Now, I have a note in my notes. We have there's a zoom option I want to try. If the zoom option doesn't work, can you set your window settings by hand?
Yeah.
Yes, and that's always, something good. But let's go into Zoom real quick, because I've written down Zoom stat, which is number 9. So if you go into Zoom, arrow down or just hit 9. Let's see what it does for us.
Oh, you see the little squiggle like that?
Huh. So, okay, I think this is one I learned about. I forget about this one every year. But Zoom stat looks at your stat settings and sets your dimensions for you.
That's nice.
Okay? Now, if we had gone into window, so they set my Xmin and Xmax at 2.28, 3.72, I would have, I would have probably said like 0 to 4, but they got very specific on us. Ymin and Ymax, I don't know why they picked these values, but they did. 14849 and 41730. Again, it includes all my Y values, doesn't it? Okay, now, to go back and answer this question, what would you say? We said negative.
Strong negative.
This goes along the line pretty closely, doesn't it?
Yeah, it's like goes down.
Okay, so I would say to answer this first question, this is definitely a strong negative correlation. So I'm just going to write strong negative as my first answer. Okay? Now, second question. Write a linear model for the demand as a function of the price of the box. Linear model. Write an equation. Now, linear, what form are we probably looking for?
Y equals mx plus b.
Y equals mx plus b. With that in mind, okay, I already hinted, we're not doing this by hand. Okay, we could, try and guesstimate this by hand, but we're not going to. Our calculator can do this for us. So are you ready?
Sure, why not?
Okay, so on your calculators, we are going to go, let's see, how do I want to, let's go back to our stat button, if you will, and hit stat, and bring up this menu. Okay, normally I hit edit and I go into my list, but this time I'm going to arrow over one to calc. And this gives me some options of different things we can do. Now, in order to write our line, okay, this is what's called writing linear regression. Okay, and if you go down and look at, there's two different ones, and we want to pick number 4, which is AX plus B. So we're going to pick number 4, linear regression, AX plus B. And I hit enter, and it's asking me, okay, X list. Were your X values in L1? In other words, what was it? Price per box, is that in L1? Okay. And that would be your independent variable. Y list is your boxes sold in L2. If not, adjust those right there, yes. And if you're happy with those, go down and hit highlight and hit enter on calculate.
What the heck?
Now, it doesn't exactly give you an equation, but yet it does. Y equals AX plus B, and it tells you the A value of negative 15,358-ish, and a B value of 73,622. Do those values mathematically make sense to you? As in, A represents the what?
Hey.
The slope. Does that slope make sense? Should it be negative? Yes, because we said it's
It's going
negative. Negative 15,000, well, it's pretty steep, so okay. B, what would B represent?
The y-intercept.
Y-intercept. Does 73,000 make sense for a Y-intercept? Well, very possibly, right? Because at $2.40, it's 38,000. So you have to keep going. Okay, so there you go. The calculator wrote our equation. Now, I'm going to write down some information here. First of all, I'm going to write my equation down, but then I'm also going to write some little reminders of how did we do what we just did. Or maybe you're already writing that down. So first of all, my equation, y equals, what do we say? Negative 15,358.92857x plus 73,622.5. By the way, did everyone get those precise values? If not, what probably went wrong? You probably have a wrong number in your list. Okay, that's the best I can say there. Now, if we round this, could we round this a little bit? We could. I have my final answer of having 2 decimal places. So negative 15,358 and 9300ths x plus 73,622 5/10. That's what I have as my linear model. Okay? Now, with that in mind, how did we get here? I went to stat, and once I was in stat, you went, whoops, over to calc. If you don't like my directions, write your own directions. We went to number 4, which was linear regression, AX plus B. And then once we had everything set up the way we went down to calculate. Okay, so those were your directions of how we did what we did. And there is your linear model. Okay. Are we good there? Okay. Okay. Got one more. And we have a couple of different options I want to introduce here. But notice what it says. Use the model to predict weekly cereal sales if the price is dropped to $2 or raised to $4 a box. So, $2 and $4. What kind of values are those? Those are X values, yes? So we want to figure out, basically, what if X is 2? What are options here?
Shall we plug it in this one?
Can we plug it in the equation? Plug it in that equation I just wrote and do it that way?
Yeah.
Yes. Is there anything wrong with that? Absolutely not. Okay. I can't introduce the other one because I forgot to mention something. Can we pause that for a moment? I meant to, and what I should have. Did we check to see if this equation made sense with our dots?
No,
We didn't. How can we do that?
I don't know.
Put it in the y.
Yeah. So like right now, my graph is a bunch of dots. Go to y equals and type in our lovely, beautiful equation.
Available?
If done correctly,
Do that to 2.
should it kind of go through the center of the dots? Yes. Okay, so that gives me confidence that some things went right here. Okay, so one option. You plug the 2 into the equation over there, yes? Okay, did you guys do that yet? Or did I sidetrack you? If we plug it in, negative 15,358.93 times 2 plus 73,622.5. You got an answer for me? I'm going to show you a way using that equation on your calculator here in a moment, but I want to just have an answer to compare against. What are we getting? Okay, 42,904.64. Now, I will say, I think you have 1 or 2 problems like this in the book. This is supposed to be what? Boxes sold, yes? Do we sell decimals of boxes? No. And what I will say if you notice all the other ones, go over to your boxes sold. What do you notice about all those? They're at least all rounded to the nearest, I'd say, tens, because they all end in 0, don't they?
Yeah.
So with that in mind, if we round this to the nearest tens, this becomes 42,900. So my approximate answer here is 42,900. And that would be boxes, or boxes sold. And that would be when the price is $2, yes? Now, if you'd already put your equation in, okay, go back to your graph with me. We have this option, and we can do it in 2 ways. I tend to just use trace. So remember, if I hit trace, now, first of all, okay, when I hit trace the first time, it comes up and tells me that I'm tracing my plot. I don't want to trace my plot. I want to trace my line. So I'm going to hit, I think you can hit the up or down arrow. Nope. Yeah. Hit your up or down arrow, and now notice, what am I tracing? I'm tracing y1. Is that what I want to use? Yeah, it's my equation. Now, what value did we just plug into that equation? 2. So now that I'm on that line, if I type 2, and remember how x equals 2 can come up down here? And hit enter. Uh-oh.
Yeah, it's what
Yeah, same here.
Ooh, crap.
Why doesn't it work?
Because I don't want to. Is it supposed to?
Yeah.
That's happened. That's happened before when I've tried to do that.
It's supposed to. Aren't I smart?
You know what?
Mm-hmm. See, the people up here.
Okay. I'm guessing. I didn't set these window settings by hand, they did. So I'm just going to go in and change my X-min to 2, my X-max to 4. I have a feeling that's why, because it was out of the window range, which is stupid. Okay, I'm going to try this again. If it doesn't work this time, I really don't know what my issue is. So now I'm going to hit trace. I'm going to arrow up or down off of plot. Now I'm on Y1. I'm going to hit 2. I'm going to hit equals, and now it works. So it was because 2 was off my screen officially. Now, is that the number we got when we plugged 2 in by hand? Okay, what's the other number I need to plug in? So I'm going to hit trace again, and arrow off of to Y1. Now I'm going to hit 4, and there we go.
Yeah.
If you can get it to work correctly, it's a little quicker. There's the if. Until you run into problems like me.
Is it a problem? I have a different number than you.
Yep.
What did I do this time?
Okay, so x equals 4. Then y is 12,186.78. Or, if we round that to the nearest tens, that is approximately,
Right.
that'd be the nearest 100.
Oh.
I'm going to go 12,190. Okay. Now, I'm going to write some notes out here. There's 2 options of what you can do. You can substitute the x value into the equation. So substitute x value into the equation. Or the other option, you can trace the line and enter the x value that way. That's if you graph the line. I guess nothing said you had to graph the line. So you could trace line and enter x value. Okay? And I will say, I had you guys go in through trace. Because that's what I do. I tend to forget. If you look in your calc menu, this is the same. If you go in the calc menu, second calc, number 1 value, it's the same thing. It might have worked a little bit better there because you wouldn't have had to go into picking which it is. So if you do second, Cal can go into number one value and just pick it, put it in. That works too. Okay. Luis, I need to figure yours out, or did you figure it out?
I never figured it out, but
So here's what I'm going to say.
hold on.
Check your y equals screen and see if you have something typed wrong there. Make sure you typed in the equation right.
All right.
Okay, guys. On homework. 82 is the big long one. It's average rate of change. You're just doing average rate of change over and over. Practice it. Look for simplifying. You give up at like part A or B, I'm not giving you completion points tomorrow. Just saying. Okay? Ask before you know, there's parts A through I. So, 53 and 68 are the two problems that are like what we just did. And I just saw a note on something. Yeah, 7 through 12 is writing an equation of the linear function y equals mx plus b. It does then say graph. Don't graph it.
Yeah, well, I found out. I fixed it.
So, okay, guys, you have a little bit of work time. Use it.
I found my issue. I think I got the different.
Okay. The other thing I'm going to write here is that what did we use? We used Zoom Stat to get a good viewing window. So if that was something you wanted to write down.
I was actually walking.